Hello, everyone, and welcome. I'm Jesse Burst with the Smart Cities Council. I'll be your moderator today as we talk about PEER, Performance Excellence in Electricity Renewal. I think it's a very important and valuable new program for utilities, and you're going to get some great how-to information today, and we're going to drill down into some case studies so you can get some real specifics as well. Three people will be joining us today to help talk about this. Ryan Franks leads the Technical and Business Solutions for PEER program at the U.S. Green Building Council, which of course is famous for its LEED certification for buildings and neighborhoods, and now PEER for utilities. And Ryan previously led a number of standardization projects at NEMA, the National Electrical Manufacturers Association. Also with us, Chris Ivanich, the Commercial and Industrial Application Manager at SCC Electric, which is a member of the Smart Cities Council and which chairs our Utilities Committee. And Chris leads application development for Microgrids, where SCC combines its medium voltage switching and its protection and its storage projects into microgrids. And Chris was previously with Thomas and Betts as a senior engineer. And also with us today, Dalia Kalata, who's application director for Smart Cities and PEER at SCC Electric. All right, so to get us kicked off, let's bring up Chris Ivanich. She's the Commercial and Industrial Application Manager at SCC Electric. Chris, welcome.
Thank you, Jesse, and good morning, everyone. Appreciate the opportunity to speak to everyone this morning. So this first slide here, what you see, the Department of Energy and Lawrence Berkeley National Lab, they identified that momentary electrical outages cost commercial and industrial users $80 billion a year. Really tremendous, $80 billion. So each commercial industrial user, they have a total average about 122 minutes, a little over 2 hours every year is their average duration for a power outage. Now, many of these electrical power outages are caused from storms that really produce catastrophic events. You know, those examples of some previous storms were the 2003 blackout, Hurricane Irene, Hurricane Sandy, various tornadoes, and even ice storms. Even looking internationally, you look at Italy, they experienced their worst power outage since World War II when a transmission line failed. The entire country of Italy, all 56 million people, wore out power for 12 hours. Last December in the UK, Storm Frank and Storm Desmond came through. They had the worst tidal surges the country has seen in over 60 years. Over 60,000 power outages because of those tidal surges. There's also other events, right? Among those outages from weather, there's also the cyber attack that we saw in Ukraine. That affected 225,000 people for over 10 hours. Today, the electrical grid in Ukraine is operated manually. There is no automation. Last spring, the entire country of Turkey, all 70 million people, again, no power for 10 hours. Finally, we've seen stricter carbon emissions throughout the world. In Europe, the European Union allowances, they established a tradable and bankable unit. Each of those allowances equal 1 ton of CO2. And last month, we've seen those carbon prices rise to over 30%, tremendous surges. And we see various states here in the U.S. evaluating the adoption of a very similar market. So what is bad planning? Painted a pretty bad picture there. Well, bad planning is not being prepared for the unplanned event. So I'd like to talk about resiliency. Well, first off, what is resiliency? Well, even for myself, I looked at it. Let me look this up in the dictionary. What is the Webster definition of resiliency? And it's the ability to recover quickly from difficulties. I think that's enough. That's pretty fair. A lot of people sometimes get mixed up of what reliability is and what resiliency is. Resiliency is the ability to recover. So why should you care about resiliency? Well, would you rather have your lights blink or would you rather have them go out? I think we know the answer. So let's take a look. What happens when there is a power outage? How do the customers incur a cost as a result of these different outages? For residential customers, you can have a flooded basement from the sump pump stop working. You can have spoiled foods. You can have accidents at intersections where the traffic lights aren't working. or the inability to go to work because it's closed due to power outage. In the case of commercial establishments, it could be the inability to pump gasoline because the pumps can't run, or to sell things in stores because the cash registers don't work. It could also be the inability of manufacturers to produce things with the power off, or computer data that's lost by any of these classes of customers. It really is devastating to a city's economy. When we think of resiliency, we should think of robustness. It's really the ability of the electrical grid to repair itself. And this is referred to as a self-healing system. So when we look at becoming smarter, what is needed to have a smarter system? Well, having a self-healing grid with distribution automation, having renewable energy generation, and energy storage. Those are 3 components. You know what those 3 components equal? That's a microgrid. So what is a microgrid? Well, microgrids are standalone electrical ecosystems. They provide backup power or complete off-grid power with the ability to produce, transmit, and manage electricity throughout the campus. Each of the devices on the grid are communicating with each other. I think the Department of Energy has a great definition of a microgrid, where they define it as a localized grouping of distributed electrical resources, loads, and a storage mechanism which can operate both as part of the central grid or independently as an island. So why should we be concerned about microgrids? Well, the way that we produce, consume, and distribute power is changing. In the blink of an eye, a power outage can begin, but a microgrid can restore that power. Microgrids are cost-effective solutions, and they can actually lower your energy cost. When we look at the old grid, it was consisted of a central generating plant and burning fossil fuel and a one-way flow of power. Today, the electrical grid is changing. It's changing to a distributed generation sources, the integration of renewable energy, and a multi-way flow of power. As we build these different components here to make the grid smarter, we look at the alternative energy sources. These can be easily incorporated into a distribution system. Some of these examples include solar, wind, cogeneration, fuel cells, biomass, geothermal, and hydro. All of these help enhance the reliability of our microgrid and facilitate the integration of renewable energy. Now, you can't have the integration of all these smart devices, all these smart energy sources without an automated distribution system. And that's what actually provides the automatic fault isolation, service restoration with the ability to island. There's a lot of utilities out there that have actually lost commercial and industrial customers to competitors who offered more reliable power service. Mm-hmm. Now, the final component of a microgrid is energy storage. Energy storage is really unique. It's got 3 attributes. It's flexible, it's fast, and it's smart. Flexible because it's either a load or a generator. It provides real or reactive power. It's very fast. The system responds accurately within a few cycles. So it prevents a small problem from becoming a large problem. And energy storage is smart. The controls adapt rapidly to the situation by making split-second decisions and they react based on energy needs. This is important because dynamic changes that constantly occur on the grid must be solved locally in real time by smart storage devices. So the benefits of the microgrid and the integration of the distributed energy sources, generation, and the reliability, all this smart grid technology, you're actually able to improve your overall system reliability. So how do you get there? How do you transition to a smarter grid? Well, let's look at the existing infrastructure. There's distribution automation already that's out there. There could be already distributed generation. You look at the existing wires. Can they be reused? Most times, yeah, they can. You look at the network. You look at the communications. And what you can do is actually build out this smarter grid in phases. So distribution automation, that's the first step to minimize your power outages. You can start slow by placing an automated interrupter at different delivery points on the grid. Next, you put in the addition of some renewable energy sources throughout the grid. And then finally, you add in some distributed energy storage and a microgrid controller. This will allow the loads to be supported during an outage autonomously. all of these elements form a microgrid. Why is this important? Well, fundamentally, a smart city starts with electricity. If you look at our critical infrastructure, water treatment facility, hospitals, grocery stores, manufacturing of food processing, distribution centers, gas stations, streetlights, they all rely on power.
Let me just underline what Chris has said. From our vantage point here at the Smart Cities Council, where we talk to cities and municipal utilities around the world, we are certainly seeing an uptick in interest in microgrids. It really feels like we're moving from those first few pilot phases into the early adopter. Some areas like the northeast of this country, often driven by resiliency and, as Chris mentioned, because of storms and natural disasters. Other parts of the world for other reasons. There's just an announcement yesterday of Africa's first microgrid. And there's places like India where, although they have natural disasters too, of course, one of the problems is the main grid is often unreliable. So a microgrid is a way for, let's say, an industrial park or something to keep up and running even if the main grid has gone down. To talk a little bit more about the Smart Cities Council and SNC and Peer, let's welcome Dalia Collada of SNC Electric. Dalia?
Thanks, Jesse. So the Smart Cities Council is an advisor and market accelerator. They promote the movement towards sustainable cities. And this is in SNC's wheelhouse, so we're committed to taking the lead in helping utilities advance cities. That's one reason why SNC is the first peer partner that has the resources and know-how to perform screenings, which you'll hear more about in this webinar. We know that U.S. electric utilities are facing some very serious challenges. For example, the growing electricity demand. Operational costs are rising, and of course, you've already seen the environmental concerns, and they are becoming more significant than ever. PEER makes sense for three key reasons. By the way, if this is your first time hearing about PEER, it is modeled after the U.S. Green Building Council's LEED rating system, and for utilities, cities, and campuses, whether that campus be university, medical center, manufacturing, office park, and so on. PEER is a fundamental tool that can be utilized to achieve our shared goal, which is creating sustainable cities. So the three key reasons why going through a screening and getting PEER certified makes sense are marketability. It allows you to evaluate your current power system performance, create a plan for improvement, and measure yourself against a third-party standard. So now you can have a roadmap to build the ultimate smart grid. The second reason is through screening, which SNC is positioned to do as a PEER partner. We can help you identify and eliminate waste to improve overall sustainability. This is done through efficiency and lower emission improvements, ultimately helping you save money. And the third reason PEER screening and certification makes sense is reliability. It gives you a comprehensive score that doesn't just look at your SAIDI and safety performance, but also your design and processes. I know Ryan has some really great insights to share with you next, so I'll pass it back to you, Jesse.
Thanks. Now let's get to the next slide, and let's bring up Ryan Franks of the U.S. Green Building Council. Ryan, welcome.
Thanks so much, Dalia, and thanks, Jesse. Yeah, so PEER, what is this acronym that we've been repeating here for a few slides? PEER is Performance Excellence in Electricity Renewal. PEER is the first dynamic adaptive rating process that's designed to measure and improve sustainable power system performance. Now, Dalia was mentioning LEED. For many of you who are familiar with LEED, this is an important slide to make the distinction of where PEER and LEED flow together. So on the left side of your screen, you'll see the blue area. That's PEER. On the right side, you'll see what is traditionally referred to as what would be encompassed by the LEED rating system in the facility. Now, PEER, again on the left, covers the generation, the transmission, and the distribution of electricity. And why is this important? I mean, it's fundamental to our core mission and our core principles because the power that supplies a facility is an integral component of what makes it green. So if you're wondering, no matter what type of stakeholder you are, whether you're a utility, a municipality, a customer, an engineering firm, whoever you are, since you have an interest on this call, PEER can help answer several questions. How reliable is my power? How can I reduce my costs? How can I improve my power quality? Where and how is my power generated? What happens if I lose power? And what are my options? This is about optimization. So what is PEER? PEER is a certification system. It's 68 different performance criteria that can get certainly very robust and comprehensive, and those fall across 4 different critical categories. So those 4 categories, just as Chris was talking about, the peer system really helps to identify and guide decision-making processes for how you make investments in your power infrastructure, and it does that through examining those 68 criteria across these 4 categories: reliability and resiliency, energy efficiency and environment, operational effectiveness, and the customer contribution. Now, we don't have near enough time to get into a comprehensive examination of all of those 68 different criteria, but to go a level beneath what we've been talking about at the surface and examine what are some of the key metrics that are in each of these 4 criteria, we'll do a little flavor of that. And why these are important, again, is that PEER is the first comprehensive, holistic way of examining what matters in your sustainable electric power system, helping you to identify where optimization can occur and helping to root out inefficiencies. So in energy efficiency, we take a look at the source energy intensity, various environmental factors like the CO2 emissions, NOx, SOx, water usage in your generation, as well as your waste recovery rate. In operational effectiveness, we take a look at your comprehensive load duration curve from a year of samples, as well as the system energy efficiency, the SEE, whether or not there's demand response capability, and the value that you're ultimately offering through your power system.
Ryan, this is Jesse, and if I understand correctly, you're not just benchmarking them, but you're also allowing them to compare themselves against benchmarks from others. Is that correct? Do I have that right?
Absolutely. One of the keys in what Dahlia was talking about in the markability of a peer score is certainly a city can go out, or a utility can go out, or an engineering firm like S&C can go out and certainly create amazing results for whoever the customer or stakeholder is. But how do you express how amazing those results are? Here's a system that allows you to do that.
Thank you.
Then finally, as Chris was talking a lot about the money that is certainly lost by outages and interruptions. In reliability and resiliency in this category, we take a look at a couple of acronyms which you may have seen floating around, but things that measure the interruption and frequency, duration of your power system, SAIDI and SAIFI, average system availability, whether or not you have an alternate source of supply, and the ability of your facility to island. On the customer contribution side, we took a look at some fundamental things like whether or not you have advanced metering infrastructure, that's smart meters, or whether you have a plan to put them in place, whether there's energy management systems available or home energy management systems available, HEMS and EMS, and really the choice that is available to the user of the power. Are local renewable resources, clean power resources available to you? Can you participate in demand response schemes no matter what they hope to accomplish? Let's take a look at some case studies here. Now, this is the Smart Cities Council, of course, and obviously the focus is on cities and municipalities. PEER can be applied to cities, of course, but it can also be applied to campuses. One that we have certified is the University of Texas at Austin, which is such a massive organization that it could really qualify as a city unto itself, of course. Just to give some background on where it is so that we can compare that with what the results are. University of Texas at Austin is the flagship institution of the University of Texas system. It has 50,000 students and 24,000 faculty. So on any given day, there's over 70,000 people. That's, a decently sized city for the United States. And what's amazing here is that it's really a leader in terms of self-generation. Since 1929, it's generated 100%, or it's been capable of generating 100% of its own electric power and thermal energy. But even while doing so, obviously, the state of Texas and the enrollment of this university has increased substantially. It's almost doubled in size and square footage between 1976 and 2013. And as a result, and accompanying that, the district energy system, that both the thermal and the electrical system that they have in place, has doubled along with that increase in area over the accompanying period of time. Now, the University of Texas has realized just tremendous value from their improvements, and again, PEER is the system that helps to quantify those. It's producing an estimated value of almost $15.4 million per year as compared to what it would be spending if it were purely connected to the local utility, which is Austin Energy. And that isn't any dig against Austin Energy in this case. Austin Energy is really a leader unto itself in many respects, having very good reliability compared to the rest of the United States and relatively reasonable cost. but it is 80% more reliable than Austin Energy than if it were connected purely and supplied by the local utility. And how does it do this? There's a variety of things. Obviously, there's the self-generation, but it's also able to automatically connect and reconnect to that utility, Austin Energy, and it's an islandable system. The system that University of Texas has put into place is very, very efficient. It has an efficiency of 87%, which is far higher than you'd find in a traditional one-way power flow from a utility. Let's take a look at a second case example here. Chattanooga, going up a bit in population, 171,000. And many of you who participate and follow the Smart Cities movement recognize that Chattanooga is a leader in this field in many ways. Chattanooga Electric Power Board is really one of the more robust municipal utilities, and it's important to recognize what they were able to achieve. It was established in 1935, and it's continued innovating since then. Today, it's one of the largest municipal power distributors. It has a 600 square mile service territory, about 189,000 customers, so those residents as well as businesses, metered customers. And in relation to the whole Smart Cities movement, of course, you'll recognize that it was one of the first companies, it was the first company, I should say, in the U.S. to offer 1 gigabyte high-speed internet service. And just recently, within the past few years, they've achieved 10 gigabit service, which certainly plays into allowing, under some of the technologies that Chris is going to talk about, to be able to communicate extremely quickly and transfer information. Directly related to that, that network enabled really a marquee smart grid in the Electric Power Board of Chattanooga to increase customer control and decrease the duration and frequency of outages. Chris, why don't you tell a little bit about what SCC was able to accomplish there?
Yeah, thanks, Ryan, for laying out the landscape here. And just so people realize, EPB, the Electric Power Board of Chattanooga, they are the electricity distribution and a telecommunications company that's owned by the city of Chattanooga. Ryan stated, there's 190,000 customers live within the service territory and 600 square miles. But when you look back when they first did this project in 2007, they had 20,000 fewer people living there. The city's economy was losing approximately $100 million each year due to power outages. And they were looking for a way, how can you improve the quality of life for the community and attract new employers along with new residents? They knew that the only way they could accomplish these goals was to become a smart city. So for them, 9 years ago, back in 2007, they invested in the fiber optic network and a self-healing grid. So as Ryan stated, they installed at the time a fiber optic network, and that was producing 1 gigabit per second internet connection to everyone within the service territory. And they deployed 1,100 smart switches on the distribution poles. So those smart switches, to kind of give you a number, when you think of their 600 square mile service territory, 170,000 customers at the time, about every 0.6 of a mile, they installed one of these smart switches, and they kind of sectionalized it by about 1 every 150 customers. So these smart switches, they actually provide an automatic reconfiguration of the distribution system after a fault occurs, and it allows the electrical line crews to go and fix the problem faster because they're going to the affected service area. So previously they had a manual system, so when a power outage occurred, the line crew would be dispatched, they would drive down the line, they would start at the source, drive down the line, try to identify where the fault occurred, drive back up, isolate the outage, make the correction, and go back to the switches. So a lot of driving, a lot of time spent. The self-healing system now, overall, it resulted in a 65% increase in reliability to the system. I mean, really tremendous. And you think about where we are today with our system, with our electrical grid. Today, people, when the power goes out, you don't want to wait hours. You don't want to wait minutes. People are waiting for seconds. That power outage to go out, to be transferred to something else, to have a faster time frame. And I think that goes for everything. I saw an ad this week, an advertisement, and it said that in 3 minutes you can save 50% on your credit card interest. And I thought about it. And if someone was going to save a substantial amount of money, Yeah, maybe you can get 5 or 10 minutes. But that's the way we've shifted now. The perspective of customers and end users and consumers of electrical power, and we want things that are corrected very quickly. And the way that you can correct issues on the electrical utility grid is through a self-healing system. So for them, when we talked about that overall system reliability, the improvement, so 53% of the outages now have been avoided because of storms. So as the storms come through and tree limbs come down and the high winds, 53% of those outages now are avoided because of the self-healing system. And that results in 42,000 outages. Really tremendous. They've actually saved, since inception of the system here, 125 million customer minutes. Unbelievable. When we look at some of the recent storms they've had, if you look at, I'll say 3 types of storms. They had a thunderstorm that came through. Because of the thunderstorm that passed through the system, they actually reduced the restoration time now to only 17 hours. Very tremendous. This was a system-wide outage. Another time, they had a large snowstorm. 36 hours. 36 hours was saved. I shouldn't say, excuse me, I said 17 hours previously. They reduced the restoration time by 17 hours. Can you imagine there? Everything that you had in your fridge would have been spoiled, thrown out. You wouldn't have been able to go to work, to take a shower, right? You need lights to take a shower. But 17 hours they saved from the thunderstorms. When a snowstorm came through, they saved 36 hours. 36 hours of restoration time was saved because of this. And that resulted even in a dollar savings as well when you look at the employees. The utility, which is the city, saved $1.4 million in overtime just from that one storm that came through because of the self-healing system. And then recently, even last year, they had some freezing rain that passed through. They had a decent number of people out, about 25,000 customers that were out of power, and it was permanent outages, and they were able to have everyone restored within 30 minutes. 30 minutes, you think about it, by the time they get the message in the previous system, the old grid, where the fault was, somebody picks up the phone, or excuse me, you find a flashlight, you get your phone, you make the call, you call the dispatch center. The dispatch center then calls the crews, and the crews go drive out. Now the crews go exactly to the right problem before you can even make that call. And some other numbers here when we talk about things, there's different indices that measure reliability on the system. There's the SAIDI, which is measuring the duration of the outage. So 42% improvement of the duration. So now they're down to an average of 61 minutes a year for power outages. And then when we look at the frequency of outages, how often it occurs, again, over a 50% improvement, so they're down to 0.6. So meaning you have less than one outage per year on your system.
These are great numbers.
Oh, yeah, absolutely. I mean, you looked at, when I talked initially just about the $80 billion a year that's lost, just starting off small, right? This is just the distribution automation piece. And we're not even tying in yet any of the energy storage, any of additional generation, renewable generation. And once you start improving all those pieces into the system, you're going to constantly keep getting better. Now, when we talk about the economy, that was one of their goals when we initially started talking about this, was how do you get more people to move to your city? They're losing $100 million in the economy every year because of these power outages. Because of the electrical grid being so reliable here in Chattanooga, they've actually have major businesses that have opened shop within the city. Volkswagen has a factory. Amazon has a large distribution center. It's nearly 5,000 jobs, 5,000 new jobs. I mean, anyone who's an employee of the utility grid or a citizen of Chattanooga, you're going to have a pretty big smile on your face to know that your city is opening new jobs and manufacturing jobs at that. Overall, right, you have to have things that pencil out, right? You have to have return on your investment. Investors are seeking alpha. And what you look at on here is over $40 million has been identified in overall customer savings because of these power outages. Their trucks, they drive hundreds of thousands of miles fewer every year. You don't have to go drive up and down. You know the exact spot where you have to go. And there's also all these, when you think about it, it's not just going to that exact location. The more time you spend driving in a car, the more of a chance you have to get in another accident, right? So it's not only time and wear in the truck, you can just start compounding all the different value that you have here from the self-healing system.
And less carbon from those big trucks and less road damage, yeah.
Thank you, Jesse. Absolutely. That's something else we need to include in here now. But the next step for them with EPB, again, they started with, I don't want to say small, but they started with just distribution automation and tremendous savings. And now they're looking at doing community solar, doing battery energy storage. And when you combine those three, again, it's a large microgrid that they're doing. I think we're going to turn it over now, Jesse, to...
Yeah, let's bring Ryan up again. And thanks, Chris. Let's bring back Ryan Franks of the U.S. Green Building Council. Ryan?
Thanks, Jesse. Thanks. So Chris enumerated many of the improvements that Chattanooga had, and just to put a cap on that, in addition to what Chris talked about, the reduced power outages, the improved reliability, the improved economy for the city, and the upgrades that produced the best ROI, some of the highlights of what they did, there's power quality measurements for 100% of their customers, which is a tremendous advancement in being able to identify problems, to identify failing infrastructure or things that may have problems before they actually fail and prevent outages. In addition, over the geographic area that they would otherwise fit into in terms of utility energy procurement, the city of Chattanooga, their CO2 intensity is 21.5% lower than the state average, which is significant. In addition, there's access to real-time data for 99% of their customers. This is a direct enabler of what Chris was talking about in terms of being able to prevent truck rolls, being able to immediately identify where along a circuit or what areas are having trouble, what areas have an outage. And finally, one of the main things that increases their reliability, of course, Chris was talking about smart switches, and what those really enable is the ability to operate on an alternative power source, to get away from this pure one-way power flow and be able to have a redundant source of energy, whether that's from another area of the grid or from renewables in some other situations. Now, I wanted to highlight a third city here. Unfortunately, the City Council hasn't quite authorized us to indicate what city this is, but a Midwestern suburb. And just to, in relative sense, they have about 100 to 200,000 people, and they're realizing a tremendous savings by having been certified through the peer process and having been able to identify where the improvements are best put into practice in their system. $17 million savings annually. This comes with a savings of $300 per customer. They're experiencing a 30% reduction in operating costs. And the point of saying all this is that when you go through the peer certification process and use our tools, you're able to generate numbers like this, or with Chattanooga, or with the University of Texas at Austin, and really make the case to a financial decision maker, make the case to your stakeholder base about why improvements are necessary. So it's worth underscoring here about how one goes through the peer process. Really what the main benefit is to utility, a city, the customers, is being able to quantify for the first time in a really comprehensive way how your electricity system is performing. What we do is we take a look at what your current performance is and what that might be if it is an existing project, what that would be over the baseline scenario. So if you're just using purely the incumbent utility services in your area, or against what type of state performance benchmarks you might have, taking a look at the value that's currently providing, and then generating numbers about what is the absolute maximum performance that you can have, the upper limit of that performance, and providing a direction, a decision-making direction as to how and what investments you can make that will increase performance across those 68 criteria in the best, most optimal way. So in practical terms, getting away from the peer paper, but peer will work whether you have an existing project or whether you're designing and developing a new project. And again, this will work for cities, but also campus environments, your typical microgrid, quote-unquote, type environment. We put you through a screening process whereby we develop a score for you. And certainly if that's high enough, that can lead directly to peer certification. But in many cases, it's not. And we can help you, and our partners like S&C can help you go through an improvement process and use several robust tools that we have in place to quantify the environmental improvements that can be made, to simulate how reliability will increase with various improvements and the like. So how to get involved. If you're an engineering firm, please join with us in a partnership. It's a great selling tool to be able to approach microgrids, campus environments, cities. If you're a facility, if you have any inkling of wanting to market yourself as a leader in power delivery, join with us and join us in participation, be able to use our tools and be able to stand out as a leader in your field. And if you're any sort of energy practitioner, please join us for education. We have several classes and courses available which can lead to continuing education units if you're involved in a LEAD program, but also just for general education. We'd be happy to set that up. The message here is that all of you who are attending have some interest in smart cities, the electric power system in some way. And no matter who you are on this call, there's some way to follow up and get involved with this. So I would really invite you to, after this webinar, take a look at our website, peer.gbci.org. And there's many pieces of information there, articles, further information about quantifying the improvements based on investment in an electric power system. You can view our entire scorecard in as much detail as you'd like to learn more about those 68 criteria that are involved in PEER, as well as get involved in the community that exists around this.
Thanks so much, Ryan. Very helpful. And for everyone, here is the contact information if you want to ask a specific question or get in touch, drill down. But before we wrap up, I'd like to ask Dahlia to come back on. And just for a moment, would you tell us a little more about the July 14 webinar and what aspects you'll be covering?
Sure, Jesse. So the topic of the July 14th webinar is about prioritizing resiliency. So we'll take a deep dive into how to leverage PEER to build a reliable and resilient electricity delivery system that protects critical infrastructure. The webinar will provide an overview of how PEER uses metrics and standards to define elements of energy resiliency, and this includes understanding how to leverage the FMEAs and the PEER reliability simulation. So the participants will also be able to learn how to define distribution automation, redundancy, islanding, and protecting essential services. So this webinar will take place on July 14th. If you'd like to register for that, you can go to the Smart Cities Council website, the events page, and register directly from there. Or you can email me directly and I'll send you some information.
Terrific. Thank you so much. Thanks to Dahlia, thanks to Chris, thanks to Ryan. Thanks to you as well for joining us, and hope to see you again on July 14 at our next PEER webinar.